Now, if you carefully see what's going on the screen is that I'm printing the first 5 records from the film table. But if you will carefully try to understand and analyze what's going on here is that for every film, you have the film ID, you have the title, description, the release year of the film, the language ID of the film. This is a null column, so let's avoid it. Rental duration, rental rate, length, replacement cost, rating, PG-13, adult, whatever it is, special features, some more text information, last updated, and that's it. And that's it. Okay. How do we know who were the actors in the film? Because if you carefully see, we do have the details of the actor that are available in the database, right? So in every film, there must be some particular set of actors, right? There must be, let's say in one film, there should be many actors, right? How can I get the details of the actor? So let's say to get the details of the actor, there is another table called as film actor. Let's try to explore film actor, okay? Now, if you will explore film actor, now what's going on is that in the film actor table, you know the actor ID who was associated to a particular film using the film ID. So every film has a unique film ID. So in that film, who all were the actors? You have a mapping of the actor ID to a film ID, right? Okay. But still, having this information also is not sufficient. Why? Because let's say now we have the film ID. For that film ID, I have to check the corresponding actor ID. So let's say on film 1, the actor ID 1 is available. Then and so on. There must be more. But still, we don't have the details of the actor. Where is the actual details of the actor stored? Select star from actor. Where is the actual details of the actor entity stored? In the actor table, right? This is the table that if you will query, you will get the actual details of the actors. Now let's have a problem statement in front of us. What is the problem statement? You want to print for every film, let's say name of the film, right? So let's say you want to have name of the film and the actor of the film. Okay. So in every row, let's say in every row, we will have name of film and one actor detail. Okay. And one actor detail. Kind of like this, something we want. So let's say if we see the film number, the first set of films. So we want some data like this. Let's say you should have a Academy Dinosaur. This is the name of the film, and then at least name of one actor. So let's say we do where actor ID is, sorry, film ID equals to 1. Okay, so these are all the actors 10, 20, 30, 40, let's say. Okay, so let's see the actors with where ID. Okay, so now let's say I want, so we have seen multiple where conditions, right? But I want a very custom where condition where I want that in the actor table, I want all those rows who are having the actor ID property either 1 or 10 or 20 or 30 or 40. Okay, something like this. So you cannot do actor ID is equals to, like one way is to do actor ID equals to 1 or actor ID is equals to 10 or and so on. You can keep on doing or like this. This is one way. Another way is, as far as I remember, is you can say where actor ID in, and then inside a pair of parentheses you can pass, let's say 1, 10, 20, 30, 40. So now what's going to happen is that it is going to check whether actor ID is one of these or not. So this will be the same or condition replaced in a shorter form. So let's say we'll do limit 5 only. One second, sorry, my bad. Let's select the whole line. And now can you see We are just getting the details of actor with 1, 10, 20, 30, 40. So now what the final response I want? I want the final response to be like Penelope Guinness. Then in the next row, again Academy Dinosaur, but with another actor, so that we can get all the actor detail. Christian, right? Christian Gable, and so on. Kind of like this, we want the details, right? So technically, the basic requirement is that the details of the film is in another table, details of the actor is in another table, and definitely films and actors are associated with each other. They are somehow related to each other. That's where the terminology for relational databases actually also come up, that the tables can be somehow related to each other. That is, a film can have many actors, an actor might be acting in multiple films, kind of like this. So this kind of an association we might have to go through, right? So how we can club all of these details which are distributed across multiple tables and give the user one final output? This is the target that we have in our hand. So now let's do one thing. Let's take a even simpler problem first, and then we will come to it. Okay. So I'll put all of these queries below. Let's take a simpler problem. So you can actually do select star from film limit 5. You execute it. You can see this is the details of the film. And you can see every film has a language ID. But looking at the language ID, we are not able to understand that, right? That this movie was in which language? Why? Because the details of the language is actually stored in a separate table. Select star from language limit 5. Kind of like this, right? This is the language table. That language ID is 1 is English. That means this movie which was in language ID 1 is an English movie. This is also an English movie. This is also an English movie. But looking at the language ID, we are not able to understand much, right? So now what you have to do is, the problem in front of you is that you have to club the results together so that you see something like this. You see a film ID, you see a film name, sorry, film title, okay, description of the film, release year of the film, and instead of the language ID, you see the language of the film. Instead of the language ID, you see the language. For example, you see 1 Academy Dinosaur, okay, description is some description, release year 2019, and in the language there should be English. This should be first row, that should come up. In the second row, you can say Ace Goldfinger, some description, 2018, and again English, and so on. Just like this, I want all of the rows. So what the task? The task is to club the results of film and language table so that we can see the language instead of the language ID directly along with the film details. Okay, so this is the problem in your hand. So I've made the problem even more simpler. We'll come back to this problem that we were discussing earlier, but I made the problem very simple for you. This is the problem that you have to club the result of the film table and the language table. Now the problem in our hand is not I would say, some kind of problem that is very unique or let's say very special. This is a very common problem, because this kind of a structuring of data you will find very regularly in production applications, and you will be required to combine the results of multiple tables together. In simple terms, this is where a new concept like joins comes into the picture. So we already talked about keys, right? If you carefully see, then the language table has a key language ID. And can I say this language ID is the primary key for the language table? And this primary key is present as a column inside film table. So can I say in the film table, the language ID becomes the foreign key, right? Now, this is where joins come into the picture. You can see that using this foreign key, two tables are kind of like related to each other. So what you can actually do is you can combine the results of these two tables. You can actually combine the results of these two tables to create a brand new result altogether. And this can be done using joins, right? So there are multiple types of join, but let me start with a very simple syntax altogether. Let me start with a very simple syntax altogether, right? So let's say I will write something like this. Select film ID, comma, title, comma, description, comma, release year, comma, language from. Okay. So what the language table has, just a second. So language table has a property name, not language, name, from. So we'll say, first of all, we'll write the name of one of the tables. So let's say the name of the table that I write is film. Okay, film table. And then I will use the word kind of like, let's say join. Okay, I'll just say join, nothing more, nothing less. Okay, I'll say join, and then I say language. Then I'll say language. Okay, let's execute this code. Let's see whether this query works. It doesn't work. What happens? Can you see the query executed properly? It is giving us the answer. And can you see, for every movie, we are getting a bunch of results, right? For every movie, we are getting a bunch of results. But these results are not correct. These results are not correct. Why these are not correct? Because we specifically remember that Academy Dinosaur movie was in English only. But here you can see it says Academy Dinosaur is in German, then Academy Dinosaur is in French, Academy Dinosaur is in Mandarin, and so on. That's not correct, right? So what exactly happened here? Let me start with that. So I'll bring a browser in front of you. Okay. So there is a concept that is called as a cross join. Okay. Or you can say outer join. What is the meaning of outer join? Let me start with that. Oh, my bad. New diagram, create. Yes. Cool. So let's assume one thing. Okay. Let's say you have a set of data. Let's say you have a set of data kind of like this. So let's say this set has 1, 2, 3, 4. Okay. There are 4 numbers inside this set. There are 4 numbers inside this set, set 1. And then there is another set, set 2, which has, let's say, 5, 6, 7. There are 3 numbers in set 2. Okay. And let's say the problem is I want all possible pair such that one element is from set 1 and another from set 2. Okay, let's say this is the problem statement in hand. Okay, this is set 1. Sorry, let's say this is set 1, and this is set 2. Okay, so what I want is I want to find all possible pairs. I want to find all possible pairs that can be created such that one element is picked from set 1 and another element is picked from set 2. Okay, cool. So how the set of pairs will look like, let me show you. So the set of pairs will look something like this: 1 5, 1 6, 1 7, then 2 5, 2 6, 2 7, then 3 5, 3 6, 3 7, 4 5, 4 6, 4 7. Okay, this is the data. These are all possible pairs that you can actually form. These are all the possible pairs that you can actually form, such that one element is from set 1, another element is from set 2. So you can say that we have prepared all possible kind of combinations between the two sets. We have prepared all possible combinations from two sets. And now if you see the response here, if you carefully see the response here, can you see, let's say in the language table, let's see one thing. How many languages are there? So let's say group by language ID. Let's just quickly see how many languages are there. Count star. Okay. So technically 1, 2, 3, 4, 5, 6. There are total 6 languages. Okay. And can you see this film? 1, 2, 3, 4, 5. Okay. Okay. Let's see how many languages are there. Okay. Let's do one thing. Let's print all the languages. So let's start from language. Let's see how many languages are there. Okay. So there are 6 languages. Okay. This makes sense. Now let's see here. Let's try to execute this code. Okay. So, okay. Interesting. Do we have any limit or something? German, French, Mandarin, Japanese, Italian, English. Okay, okay. We are getting 6 only. So you can see for this Academy Dinosaur movie, we are getting 6 records. Then for the next movie, that is Ace Goldfinger, we are again getting 6 records. Right? Can you see it's kind of like similar to this? One is having 3 records here, 1, 5, 1, 6, 1, 7. 2 is having 3 records, 2, 5, 2, 6, 2, 7. 3 is having 3 records, 3, 5, 3, 6, 3, 7, and so on. Can I say that? So we are kind of like preparing all the possible set of combinations. This kind of a scenario is called as a cross join. This kind of a scenario is called as a cross join. Okay. So technically what happens in a cross join is that in a cross, and this cross join is also called as the outer join. Cross join or outer join, or you can say just join, So this cross join, outer join, or just join, what it actually does is it kind of like creates a cross product, or all the possible combinations of the elements from the given two tables altogether. This is the use case of outer join. Okay. And this outer join is supported by MySQL. So this query technically does outer join. So I'll copy this query and maybe paste that query here. Okay. This is the query. And this is what outer join looks like. But definitely this doesn't solve our problem. This was not our problem. We didn't want the combination of all the possible elements in both of the tables. We wanted that Ace Gold Academy Dinosaur movie is an English movie. So in Academy Dinosaur language, or I would say name property, it should just say English. Currently we are not getting that. We are getting multiple records that actually doesn't make sense. Like this record doesn't make a lot of sense, that Academy Dinosaur is in Japanese, because it's not. You can see the language ID, the language of the movie was only English. So our problem still remains as it is there, that how can we exactly get Academy Dinosaur to English, then Ace Goldfinger to English, and so on. So in SQL, there are other types of joins available as well. Okay. One of the other type of join is called as a inner join. So let me first of all show you the query and then I'll explain. So let's say we do release year name from film, and I say something like inner join. I say inner join language. That's it. Okay. Nothing more, nothing less. I just say inner join. So from the join keyword, I have changed this to inner join. Let's see what happens. If I execute this code, executing this code still made no difference, right? It's still kind of like, if you carefully see, still kind of like looks almost the same. But inner join actually supports one operator. right? Using which you can actually combine the data based on a common attribute. So in the inner join, you can actually say something like on film dot language ID is equals to language dot language ID. Okay, so what we have done, we have sent on, let's call it as inner join. We say inner join language, film inner join language on, in the film tables language ID, it should be equal to language tables language ID. So what we are saying is that I now don't want a cross product altogether. What I want is that among that cross product, try to see that in the films table, whatever record you are picking from the films table, on that record, what's the language ID, and then map it to the same language from the table of language. So now if I run this query, now can you see Academy Dinosaur comes with English, Ace Goldfinger comes with just English, and so on. There are some Italian movies like Alone Trip, so it is coming as Italian. Now it is not creating a combination of all the possibilities from the two tables, right? So you can say that inner join is kind of like outer join plus some filter is equals to inner join. So if you can provide a common attribute, what was the common attribute? Language ID, because this was acting as a foreign key, right? Then based on this common attribute, you can actually filter out the elements that were coming from the outer join. And this makes inner join, right? So you can say it's kind of like a conditional join altogether. Okay. And this is the result that you are going to get. This is the result that you are actually going to get. So inner joins are very powerful. Inner joins are very powerful, and you will see in a lot of production level code, inner join are one of the most sensible ones. So if I actually want to represent inner joins, no, let me represent inner joins like this. So let's say you have a circle, right? Then you have another circle. Okay, so let's say there are two circles like this. Okay, and let's say cool. So this is one circle. Let's also remove it. Okay, this is one circle. I will call this one as set A, set 1. This is another circle, kind of like set 2. And can I say that this part is what? This part is kind of like intersection of the set. Intersection of sets. Right, this is the intersection of set 1 and set 2. So this part where the arrow is coming up, this particular part, right, what does this part represent? This part represents the common set of elements in set 1 and set 2. So whatever are the elements that are present in both set 1 and set 2 is actually represented by this common region. And think about inner join. Previously we were getting all possible combination, the element that are just in film and the element that are just in language getting combined in all possible ways. But now we are not doing that. We are having a common property, right? We are having an intersection, that Academy Dinosaur is just available in English. So we took the common property language ID, and based on that common property, we actually kind of like filtered our data. Right? This is a very powerful operation, right? This is a very powerful operation. And that's why inner join is kind of like very useful for most of the use cases that you are going to have, right? So just to summarize, what is outer join? In outer join, you have all the possible combination of elements from first element to second element. In inner join, what you do, you don't get all possible combination, but instead you do a sensible combination. Sensible combination in the sense that a column that is common in both of them, that is, one will be most probably primary key of the other one, second will be kind of like the foreign key. Second table will be having the same column as foreign key. So on that foreign key, you start the mapping. On that foreign key, you actually start the mapping. So now you're not going to get all possible pairs. It's like the element on set 1. So first element of the set 1 is just mapped with 5. Second is also just mapped with 5. 3 is mapped with 6. 4 is mapped with 7, and so on. It's kind of like that. Okay. So we're talking about inner join. Okay, we're talking about inner join. So in inner join, you actually do a combination of both. This is the query that you can actually use, right? Put the query here. Right, this is the query, and using this you can actually get a combination of the results coming from both of them, right? This is a very, very interesting approach, and inner join actually contributes a lot to the actual code basis. So I hope the overall basic logic about the cross join, or you can say outer join, along with the inner join, is clear to everyone. So now you can see I have the details of the both the tables individually. This is just the film table, this is just the language table, and now you can see language ID, this language ID here. This is the primary key for language table. Okay, and here it is a foreign key for film. This is a foreign key for the film table. Okay, and now if you see how the mapping is there, this agent Truman, you can see this one is mapped to language ID 1, right? This one is mapped to language ID 1, right? This one is also, the second record is also mapped to language ID 1, right? So multiple movies are actually mapped to the same language. Let's see more. This one as well, and this one as well. Okay, so let's make it red. Let's make this one also red. Okay, cool. And now there are a bunch of movies like this which are mapped to 2. For example, this one, or for example this one. Okay, if you see these movies, these are mapped with language 2. So what concrete logic we are able to draw? If you see, some of the movies are having the language as 1, some of the movies have language 2, but one thing is for sure, that is every language, every film has one language, right? Every film has one language, but a language belongs to multiple films, right? So we can say a film has one language, but a language can be of inside multiple, I would say, films. This is a very important fact in front of us, and you will see these kind of combinations coming up a lot, where one table is associated to other. This is a classical example of association, that one table is associated to other with some relationship going on, that a film has one language and a language belong to multiple films. For example, language 1, there you can see 4 films are there, language 2 is in more than 6 films, and so on. So one language can belong to multiple films, but one film only belongs to one language. This is actually called as, if we read it from kind of like left to right, so you can say, if we read kind of like film to language, then you can call it as, I would say, many to one. That is, one language can be of many films, or you can say it like this, or you can say language to film as one to many. That is, one language has many films, and many films belongs to one language, or I would say, sorry, every film belongs to one language. This kind of an association is actually called as a many to one or one to many relationship. Anything you can say based on which table you are reading first. Generally people call it as a many to one kind of a relationship, right? So in this relationship, what happens is one table, a record of one table might be associated with multiple records of other table, but records of the other table is only associated with one record of this table. You can see one language ID is in multiple tables, oh sorry, multiple rows, but every row only have got one language ID. So this is called as a many to one relationship. Now let me give you more examples of many to one relationships. Okay, so let's see. If I say address, okay, if you see for every address that you see, can you see every address has a city ID? Because whatever house you are in, you will be living in some city, right? And if you carefully see, there is a city table inside which also there is a city ID city, right? That means one address belongs to a city. Can I say that your home is inside one city, right? You cannot say that this same address that is owned by me is in multiple states. No, that one address belongs to a city, and one city can have many addresses because there can be multiple houses, right? Same thing, one more you can see. In city, you can see city has a country ID, but country doesn't have a city ID. Why? Because one country can have many cities, but one city belongs to a country, right? For example, New Delhi. New Delhi is going to be considered only in India as well, only in India altogether, right? So every city belongs to a country, and one country has many cities, right? This is called as a one to many relationship or many to one relationship, whatever first table you are reading. In generally, what happens in a one to many or many to one relationship is that one of the tables contain the foreign key, which is a primary key in other table, and this kind of a repetition you actually see. That's the sign where you have one to many or many to one kind of a relationship, right? And this is the first association that we have actually discussed here. And you can see, to get the query result of this first association, inner join is going to be super helpful for you. Now sometimes there is one more type of a association. Let me actually show you. So you already have the films record, right? You already have the films record. So copy. Let's do one thing. Cool. Now let's think about it like this. More or less, or instead of printing the table, let me describe the table. Okay. Describe film. So, okay. So this is the description of the film table. Okay. If you see the description of the film table, we'll be able to analyze one very interesting fact. You can see inside this film table, there is no discussion about the actor. But we know that in every film, there are multiple actors, and one actor can do multiple films, right? So let's see the actor table. Describe actor. Okay. This is the actor table, right? This is the actor table altogether. Cool. Now, even in the actor table also, you can see there is no discussion about the film, right? Array table and film table are related because one film has many actors and an actor belongs to multiple films, right? So, there is a direct relationship that definitely exists between both of them, but how can we establish that relationship? How can we actually make that relationship work, right? What is the relationship? That a film has many actors film has many actors and an actor must be doing multiple films. Okay. So, yep. This is the relationship between these two tables, that a film has many orders, many actors, but an actor can also belong to multiple films, or it must be doing multiple films. Okay. So you can see there is no discussion about the actor ID and the film ID, but they are related. So how can we do combine them? Because let's say now I want to combine these two tables, right? I want to combine the table film and I want to combine the table actor. Previously, when we wanted to combine, there was a foreign key. Previously, when we wanted to combine, there was a foreign key, right? But this time, there is no foreign key. If there is no foreign key, what can be done? So what happens is that in this kind of a case where a film has many actors and an actor must be doing multiple films, this is a classical case of a many to many relationship. So this kind of a relationship that occurs here is kind of like many to many. Okay, many to many relationship. In a many to many relationship, what happens that one table, the records of one table might be belonging to multiple records of the other table and vice versa, right? And that's why this is the reason there is no foreign key that we directly see in the core tables. You can see there is no actor ID in the film table and there is no film ID in the actor table, because just think about it. If multiple actors are doing a film, that means either we need to maintain an array of actors, right? One approach will be to maintain an array of actors, right? That here we store an array of actors and here one actor must be doing multiple films, so we store an array of films. But now there will be significant problems by storing the arrays. What all problems will be there? Just think about it. Let's say in the film table we store an array of actor ID. Now if I want to know what all films one actor is doing, then I have to separately store that array of films in the actor ID table, in the actor table as well. So we have to store arrays in both of the tables. It's not like you can just store an array in one table. That's the problem, right? Okay. Now let's say what do I have to do is I have to update an actor in a film. Okay. Then what do I have to do is I have to go to that particular film, add that actor's ID. Then I have to go to this actors table here and then add that film in the in the film ID array as well. So we have to do updates at multiple places. So if we have to remove from multiple places, right? So let's say we are going to delete an actor. Let's say we have to delete an actor. Then inside my film table, every row is having an array of actors, because let's say I want to now remove an actor from the industry. Now that actor is no more available or something happened, but that actor might be doing multiple films. So what we have to do is we have to go to each film row, each film record, get the array inside each film record, search for that actor in that actor ID array, and then remove it. Think about it like this. So think about it like this, that let's say the films table, let's assume for a moment, has an array of actor ID, and let's say all these 10 films were having one common actor with an actor ID 1. But now I want to delete that actor from my record. What do I have to do? I have to go to this particular first row, access its array of actors, and then remove the actor from here. Then do the same thing here, do the same thing here, do the same thing here, and so on. This will be a very time consuming task for us. That's why especially for many to many relationships, which are kind of like a bit tricky, we create something called as a through table, right? We create something called as a through table. What is a through table? The through table helps us to combine the two tables in many to many relationship. And for our use case, the through table is film actor table, right? This through table is the film actor table. Sometimes this through table is also called as a join table. Sometimes this through table is also called as a join table. Now if you carefully see now, both of these tables are now kind of like associated with this third table. Both of these tables are kind of like associated with the third table. And now you can see we don't have to store an array inside the film's record and or inside the array, actor's record, because now what happens is that every row of this through table or join table, so this is the through table, this is the through table, okay, so every row of this through table or join table is going to be belonging to an actor ID and a film ID, right? And it will look something like this. Okay, let me remove the film ID value filter. Right, can you see? Now what the first record mentions, the first record says that actor with actor ID 1 is acting in the film ID 1. Actor with actor ID 1 is also filming in the film ID 23 and so on. Now think about deletion. Let's say if I have to delete an actor ID 1 from my records, I can very easily do that. You can say delete from actor where actor ID is equals to 1. Now you don't have to parse through all the rows, then traverse on the arrays and then remove the record. You can directly do that here, right? You can directly do that. So that's why through tables are pretty powerful. Whenever you have a many to many kind of a use case, in this kind of a use case, through table becomes extremely handy for us, right? So whenever we have to now join, let's say now the situation is that I want to have the film name and the actor name. Now I cannot just directly join them, right? Because they're not directly related to each other. This film is having no actor ID, this actor ID is having no film. So, but we want to join the data because joining is what? Combination of tables. So this time the join will happen via the through table. This time the join will happen via through table. Let me show you. So we can say select film ID, title, right? And let's say what else? We need the first name from. Okay, so let's start. So you can start with any table. You can start with any table. Okay, let's say we start with the actor table. So I'll say from actor inner join film actor, right? So what we are going to do is we are going to first of all create a join of the actor table and the through table. So we are going to join them. And now if forget about the first film table, if you just look at the through table and the actor table, can I say actor table's primary key is what? Actor ID. And that primary key is present as a foreign key here. That means I can do something like this, right? On actor dot film ID is equals to film actor dot film ID. Okay, something like this. So let me bring it in new line. Okay, so you can see what I'm doing is I'm saying actor should do a inner join with film actor. And what is the foreign key? Film ID is the foreign key, right? Sorry, my bad. Actor ID. Actor ID is the foreign key. So we are going to join based on the foreign key altogether. But this doesn't solve the whole problem for us because currently I have joined actor table with the film actor table, right? So for a moment, if I do select star, can you see actor table got combined with the film actor table? See, actor table got combined with the film actor table, but that's not our agenda. Our final agenda is something else. I want to combine it on film. So now what happens is that whenever you do an inner join, it kind of like creates a temporary view of the table altogether. And on that view, again, you can put a inner join. So you can say inner join. And this time you are going to join the film table with the actor table, film actor table. So you can say film actor dot film ID is equals to film dot film ID. Okay, kind of like this. Inner join film like this and film actor let's see what is the error. Oh sorry, my bad. Inner join, we should say on. We should say on. Okay, inner join fill. Okay, so now you can see we are first joining the film actor and the actor table. Whatever is the result of that, we are joining it with the film table. Let's see what comes up. One second. Okay, so there is a error coming up. Film ID it was not able to find. Let's see what is the column. Film underscore ID. Film dot film ID. Film actor dot film ID. Film. Film actor. Okay. Let's see. What's the error? Okay, got it. Now you can see the error that is coming up. If you will carefully read now, the error says that the film ID is ambiguous. Why the film ID is ambiguous? Film ID is ambiguous because the thing is that when you actually combine these two, just carefully see, carefully see. If I just combine the film actor and the actor table, one second, this was working just now, right? Select film ID comma title comma first name from actor inner join film. Okay, let's do a star for a moment, then we will resolve it. Okay, cool. Now if you carefully see, the property actor ID is present 2 times. You must have never seen something like this, right? That at any point of time, no 2 columns gets repeated, but it is getting repeated here. Why it is getting repeated here? Because this actor ID is coming from the actor table, whereas this actor ID is coming from the film actor table. So now in the combination result, we have 2 actor ID columns. That was the problem that was actually shown. That was the problem that was actually shown in the error. That this film ID, this title, this first name, these are ambiguous because there can be multiple occurrences because you just combined those tables. Just think about it. If let's say you have a file which is having some records, you have another file which is having some more records, but there is some combined data in both the files. If you just combine them together without removing the redundant data, then you will see the redundant data, right? So that's why you can see for first name there won't be any redundancy coming much because it's not in the film actor, right? So that's why when you say film ID, you can just say film.film ID and you can say film.title and let's say actor.first name, something like this. If now I execute it, now can you see what's going on? I have the film ID, I have the name of the movie, and I have the name of the actor, right? So what happened is there was a many to many relationship. We combined them using the through table. So we first did the join between actor and the through table. Then whatever was the result, I did a join with the film table. As simple as that. This is also a direct application of inner join, that you will be able to combine multiple tables together if somehow somewhat they are related to each other. Now there is one more type of join that a lot of times you will see people actually using, kind of like self joins. Okay, so what is a self join and how can you actually resolve it? So let's think about it like this. Let's say you have an employee table. Okay, you have an employee table. Okay, right? Now these employees might be some normal employees or they can be managers as well, right? They can be managers as well. A normal employee can be a normal employee, or they can be a team lead, or they can be a manager, kind of like that. They can have different designations altogether, right? Okay. Now, in this case, let's say we want to figure out what all employees are actually managers as well. What all employees are managers as well, right? We have to, let's say, figure that out. How can we actually do that? So first of all, let's try to figure out how the data should look like, right? So let's say every employee will be having an employee ID. Every employee will be having an employee name. Okay. And let's say every employee will be having a manager ID. And this manager ID will be another employee altogether. This manager ID will be another employee altogether, right? This is something very interesting. This is something very interesting. So let me bring an example in front of you. Let me bring an example in front of you. Okay. So kind of like this. Okay. So if you carefully see here, employee with ID 1 has a name Alice. And who is the manager of Alice? Manager of Alice is employee with ID 3. Who is employee with ID 3? Carol. So Carol is the manager of Alice. Now, who is the manager of Bob? Carol is the manager of Bob. Who's the manager of Carol? There is no one who is the manager of Carol. Who's the manager of Dave? Alice is the manager of Dave. Who's the manager of Eve? Bob is the manager of Eve. So if I show you how the structure looks like, so at the top there is Carol. At the top there is Carol. Now below Carol, you have Bob, and then you have Alice. Then below Alice, you have Dave. And below Bob, you have Eve. This is the hierarchy in the organization as per the current records, right? So you can see that this manager ID actually is a user ID only. Manager ID 3 means it refers to user with the ID 3 or employee with the ID 3, right? This refers to the employee with ID 3. So you can see that in the same table, you are using primary key as a foreign key, kind of. You can say that this manager ID is kind of like the same primary key, just referencing some other records altogether. In this kind of a case, we use something like a self join. In this kind of a case, we use something like a self join, right? So you can write a query like this. You can actually write a query like this. Okay, so you can write something like select table1 dot employee ID from employees as. So what is this as keyword? As keyword helps you to put alias, kind of like nickname, right? So you can say employees. So you have employees table. You are first of all calling employees table as table1. Now you have to put a join, but you do not have to put a join with another table. Can you see? Previously we were always putting join with another tables. This time you need to put a join with the same table. So you just say join and then put the name of the same table and then write as table 2. So these two aliases are going to make sure that you are able to refer to the same table twice. On table1 dot employee ID is equals to table2 dot manager ID. Now table 1 also refers to the employee table, table 2 also refers to the employee table. So you're actually talking to the same table, but this time you are putting a join with respect to two different columns of that same table. This situation, this kind of a situation is called as a self join. This situation is called as a self join altogether. Now there are two more types of joins. One is a left join. So we already saw what is inner join, right? Inner join was intersection of both of the sets. What's a left join? Let me show you the image of left join. Okay. So in left join, you can see what's happening is you have all the records which are common in table 1 and table 2, and all those records which are just in table 1. This is left join, kind of like this. Okay, so let's see. So let's say there is a student table with student ID and name of the student. Then there is a department table with the student ID and which department the student belongs to. And now you are doing a left join with A and B. So can you see you have a student, like now what will happen is, because if you see the diagram, what this diagram says that all the records of table 1 plus the common records of table 1 and table 2, right? Cool. That means let's say, now how many records are there in table 1? There are 4 records in table 1. So in our final output also there will be 4 records. That means all the records of table 1 will come. But now if you carefully see, for student number 1003, there is no department mentioned. In this table, there is no department for student number 1003, right? That means there was no common data for 1003. There was no intersection of this first table and second table for 1003, right? So for 1003, there is null. Same for 1002. There is no department for 1002, null. 1001, there is no department for 1001, null. But for 1004, there is a department. So you can see now the department is coming up. So what it denotes that all the records of table 1 has to be in the output. But after combining it with table 2, there can be a case that table 2 doesn't contain their record. You can see the table 2 is not containing records 1001, 1002, 1003. So there can be a case that you do not have the common. Now just think about it like this. If you will put an inner join here in this table and this table, if you put an inner join, in the inner join you only consider common data. Which data is common in these two tables? Only 1004 is common in both the tables. So you will just get one row using inner join, because inner join works on the concept of common combination. In left join, you will say that okay, 1004 is common, no problem. But I don't just need 1004. I need all of the records of the student table. Can I say that? That means all records of student table are coming. But the problem is there is no common record in student, in the table 2. So whenever you won't be having a common record, for those columns which don't have a common record are going to have a null property. Otherwise, they will be populated with their own property. So let me show you an example, and let me also show you how you can actually do that. So okay, let's say we say select star from film actor, and if you want to do a left join, you instead of inner join you say left join. That's it. If you write left join, it will be a left join. Film on and film actor dot film id is equals to film dot film id. Let's execute this code and let's do one thing. Let's only take a film name, that is the title, and let's only take okay, let's keep it like star only. Okay, and now let's see. So I guess on this table we don't have much of the records which can be null. Okay, so let's try another table. Film category is there. So do we have a category for the film? What's film category? Film ID, category ID. Okay, let's do the same thing with category. Okay, we're going to do category left join film category, right, on category dot category id is equals to film dot category id. Let's try to execute this and let's see. Okay, so we have a film for every category. We have a film for every category. Okay, let's do one thing. Let's insert one entry in category. Okay, so these are the three things you need for category. So let's do one thing. I'll say insert into category. We just need to put name. Let's say values. So I need a new category, horror sci-fi, or I would say documentary. Okay, new category, documentary. Let's insert it. Okay, inserted. And now let's execute the join query. Okay. Now, can you see that all the records of category are coming? If you see how many total categories do we have? Select star from category. We won't be having a lot. So if you see, you can see we have total 17 categories altogether. Okay. Oh, a documentary I made same. Let's change its name. So I'll say it as what should be the category? Reality show. Let's keep it like reality show as a category. Okay, cool. So now I have made a new category, reality show, right? Just I made it. And now if I do a if I do a left join, can you see every category is coming up? Action, animation, children, all the categories will come up. And in fact, our last category, okay, this is still showing documentary. So I believe it's not taking the latest data, is it? Sorry, let's see in the category, did it exactly change the name? It has not changed the name. So let's call it as reality show. Okay, apply. Okay. Now let's go with the left join. And can you see, even the record of reality show is coming, because I want all the records of category table. Because on the what is on the left side of this join, category is on the left side of the join, film category is on the right side of the join. Okay, so I want all the records of the category table, but there can be a case that there is no intersecting record between category and film category for a particular category. For that case, you will get null, null, and null. But the moment it is able to find a corresponding common point, for example, let's say travel was a common category in both the tables. Animation, sports, sci-fi, all of these were common category in both the tables. But only reality show was a category which was not common. And that's what this Venn diagram also represents. That all the common parts like travel, sci-fi, sports, these are common part. And all those part which is just present in A but not present in B. This is that part. This is the common part. And this is the part that is outside. This is the elements that are just in A but not in B. So which element is just in category but not in film category? Reality show is the element which is just present at one place. This concept is called as left join. And if you apply the same concept, so this is the table on the left, this is the table on the right. If you just apply the same concept for the table on the right, that becomes right join. Can you see? Right join is exactly same as the left join. It's just that, let's see. If I put film category on the left and category on the right. Okay, so now I say film category, left join category. If I execute this code, you can see same output is coming. But this time you will not see. Okay, let's see. So film category, this should say right join. You should say right join, no? Can you see the same output is coming? Again, reality show with a bunch of nulls here. So right join actually first, like, what is the meaning of right join? In right join, that table mentioned on the right, all the records of that table is taken. In left join, the table mentioned on the left, all the records of that table is taken. Whichever is the table for which we are taking all the records, and let's say in the corresponding other table there are few records which are not present, then we will get all null together. This is called as left join and right join inside SQL.